Welcome to Atomic City. Here we meet the isotope triplets, three versions of the same element, carbon. They were born in the heart of stars, but here on Earth they've grown into very different characters. Same element, different powers. Wanted in Atomic City, the carbon triplets are on the loose. They may look different, but here's the twist. They're all the same element, carbon. Each brother has 6 protons in his nucleus. That's what makes them carbon. But their neutron counts vary, and that's the key difference between isotopes. Isotopes are atoms of the same element that share the same number of protons but have a different number of neutrons. These brothers may share the same name, but each one has a very different story. Let's take a look at them one by one. First up, C-12 the Diamond Crusher is the most common triplet. About 99% of all carbon atoms are carbon-12. Stable and unshakable, he never breaks down. He forms the basis of diamonds, graphite and living things, and he defines the atomic mass scale for all other elements. 99% of carbon, 100% unstoppable. I will crush you. C-12, strong, stable and solid as a diamond. Next, meet Carbon-13 the Spectral Scanner. He's the ghost of the carbon triplets, silent but always watching. Unlike his brothers, he doesn't smash or decay, he tracks and reveals. He can slip into living systems undetected, exposing hidden secrets. Science uses him as a tracer isotope to follow molecules inside the body. You can't escape my gaze, I see secrets within. Carbon-13, stable, clever and a scientist's spy in the world of atoms. Finally, the last brother, Carbon-14 the Radioactive Reaper, is the most unstable of the carbon triplets. Glowing with radioactive energy, he's feared across Atomic City. He slowly breaks down over thousands of years, but that makes him incredibly useful. Scientists use his decay to unlock the age of fossils and ancient artifacts. Time is my weapon. I reveal the past and decay the future. Carbon-14, unstable but essential for uncovering the secrets of history. Now that we've met the brothers, let's reveal the science behind the story and what exactly are isotopes. Isotopes are atoms of the same element with the same number of protons but a different number of neutrons. That means behaving the same chemically because their protons and electrons are identical, but their mass is different. Some are slightly heavier or lighter versions of the same element. Some isotopes are stable like carbon-12 and carbon-13. Others are unstable or radioactive like carbon-14. Here you can see the difference. C-12 has 6 neutrons, C-13 has 7 and C-14 has 8. Same element, different mass. So why do isotopes matter? They show us the hidden variety inside elements. Even though atoms look the same on the outside, different numbers of neutrons give them very different roles. Stable isotopes like C-12 and C-13 are safe and always present in nature. They make up the carbon in our bodies, in plants and even in diamonds. Unstable isotopes like C-14 are formed naturally in the atmosphere, absorbed by plants and animals and decay slowly after death. That decay forms the basis of radiocarbon dating. So let's summarize everything we've learned. Isotopes are atoms of the same element with the same number of protons but different numbers of neutrons. That means they share chemical properties but have different masses, and sometimes one of them is radioactive. Carbon-12, carbon-13 and carbon-14 are the perfect examples, but isotopes aren't just about carbon. Hydrogen, uranium, iodine and technetium all have vital uses in medicine, archaeology and energy. So remember, same element, different neutrons, and a world of powerful possibilities.